Hello, it's Bart from Nature Manufacturer. This time I will show lake object, the simple lake object, not the sea, because the sea will get separated tutorial as it sea shaders need a bit more options to talk about. We will play with this simple lake object. So, first of all, to create a lake object, we find a nice place. We click 3D object, Nature Manufacturer, click polygon. With Control, we place points. With Shift, we could place, by holding Shift, we could place points between points. With Control Shift, we could remove them. Of course, you could move points anytime, but if you want to move it higher or lower, you have to uncheck lock high option. It's because the most of the lake objects doesn't need a height difference between points. But if, for example, it's lava lake or kind of pavement, probably you would like to uncheck this option. Okay, so let's check the profile. So maybe not swamp. Yeah, let's take this yellow lake. And of course, this lake is out of the box. You could expand it anytime and it will remake all this flow map and other rules. So just get lake out of the box. And to talk about mesh settings, we would rather have to maybe, first of all, change material to debug and move this lake a bit. Okay, so we'll see only the words. In the wireframe mode, we see how the triangles on the lake are distributed. And we have a number of triangles which we spent on this lake. And there is a maximum triangle amount, which is clamp. It may happen that you create huge lake with small maximum triangle size, and it would generate huge amount of triangles and slow down your engine. To avoid this situation, we set clamp value so the engine will do not slow down even if you will make such a config by mistake. If you don't do this by mistake, you will simply expand the maximum triangle amount. You could change the maximum triangle size to lower values to make your lake more detailed, or you could simply set up higher values just to hold low triangles. With spline density, you could change the shape of the border. For example, this shape would be more fit the pavement, while the mesh with nice curved edge would fit the lake. So let's maybe go to shaded mode, and by UV scale you could modify tiling on the lake. So yeah, you have control over UV. Depth and directional map is for C system, and I will explain these features in C shader and C object. So let's maybe skip this part for now, and I will explain it later in another tutorial related to C and shader which really use this function. Let's restart the profile and what we could do with this lake. We have a panel which is used for making holes, so let's maybe make another lake, or it could be a simple spline object, and we drag and drop it in as a lake hole, and we have a hole in the lake. Let's maybe turn off the mesh inside this hole. And when we use this, if we have a huge lake or sea, and we want to put, for example, mesh under the island, and we don't want to spend triangles under the island for a sea or lake, we simply place a hole. Another option at lakes is snap mesh to the terrain. Basically, it will snap that to the collider under the lake. It will do this in resolution that lake has. So if you have a too low resolution, you will get such an effect. If you will increase the number of triangles, you will simply get better cover. when it's useful. Maybe for lakes, like water lakes, probably it's not so useful, but for example, if you want to place lava lake, it rather will be snapped to the terrain. For example, if you have 8 layers on the terrain and you want to place another texture on the terrain, sometimes it's better to use a lake, place a additional texture with mask, right, on the material, and snap this to the terrain. So you don't have to waste any additional textures as a layer on the terrain, because you could simply use a lake object. We did this, for example, for lava lake or lava place with emission in a specific terrain part. Okay, but if you snap or carve or paint terrain, you use layers. And remember that you could exclude something from layers detection, from collision detection. So specific objects could do not affect the lake snapping. Or also remember, if this layer is used for carving and painting, if terrain will be on the layer that is excluded from layers, simply lake will do not detect it, and it will not carve and do not paint this terrain because it's on the layer which is excluded from the collision detection. Okay, but beside that, you could snap lake to the terrain. You could also take normals from the terrain or any collision that is under the lake. What will happen if we click that here? First of all, we have a lake material. It's the same material as the same shader as the on the river, and if we take normals from the terrain or collision under the lake, we pass that on the border of the lake we get slope, because in fact we have a slope under the lake because the terrain simply is carved by the lake and we have a slope. So we pass this slope to the shader, and like in the river, if we have a slope, we have an effect that is based on slope. In fact, we have a waterfall. To be honest, if we snap lake to the terrain as a mesh, we rather want to take normals from it, so the normal of the object will be proper. In the lighting settings, we could set if this object should cast shadows or not. Probably in most cases, we rather don't want to use cast shadow. First of all, water doesn't cast shadow, and if you snap something to the terrain, it also does not cast shadow, so it's waste of source to cast shadow. In optimization mode, we could make few things. First of all, let's maybe change the material to the debug mode without tessellation, so we'll see the triangles. And let's open this optimization. In a wireframe mode, we will see all effects. First, we could split our lake into submeshes. It's useful when you have a huge lake and we want to avoid mesh that is huge. I mean, it have a huge number of triangles. In fact, there is a situation, for example, when we have a really huge lake, and if it would be as a one mesh, anytime you will look only on the part of the lake, you will get triangles on the screen from the object. So you will render the whole triangles. You will get rendering from all triangles on the screen. So if you will cut it into parts, you will have this mesh in a path. So if you will look only at the visible part of the lake, you will only render on the screen the visible part of the lake. So this is kind of nice optimization. It works pretty okay, but you could decide how many parts of the lake you want to have. Bigger number of parts probably will mess a bit this lake, but with lower amount of parts it worked really well, and you could optimize a bit the rendering on the screen, especially for bigger lakes or with very specific height, or for example for a sea. You don't want to render whole sea as a one mesh. Basically, the best option for a sea object or lake, the huge lake, is the generate LOD system. But first of all, let's decrease amount of triangles on the mesh, and let's expand the lake amount, the lake size, so it will be huge. Yeah, let's make a huge lake. And what will happen? First of all, when we expand the lake object, we get huge amount of triangles. Of course, we could reduce the amount of triangles just to have a fast refreshing when we edit that. But the disadvantage of this situation is that, first of all, any data that is saved as a flow, like for example, like flow map or vertex color, depend on triangle amount and triangle size. So we decrease the resolution of this effect. If we use tessellation rather like mesh which have a equal borders of the triangles. And if we expand the lake, we reduce the quality of the lake just to keep it fast. And there is a solution for that. If you will click generate LOD system, it will generate additional triangles only to the if camera is close enough. And this effect is enough for a sea or lake object, because first of all, in the far distance, keep a very low resolution object, but when the player or user is close enough, we make the mesh detailed enough for the all effects that use triangles. Of course, you could manage when and how far this LOD system generates, so you have full control over this setting, and this is the base for our sea and ocean or huge lake objects. And of course, you could use GPU system, not only CPU system, but it's in preview and seems actually it's slower than CPU. So we rather advise you to use CPU system. We will expand GPU system. We will work on it so it will get better performance. But actually, CPU system. Refreshing time is how often do you refresh the triangle information when your camera is movement. Higher values will be much faster, but you will notice, for example, changes on the screen, how it jump. Lower values will generate smooth effect, but it may cost a bit more CPU or GPU. Okay, so that's all for the LOD system. Let's go to the other parts of the lakes. Okay, so we're back to the shaded mode and let's go to the points. And you may notice that if we go to the wireframe, we have a point here, and we could modify the number of triangles on the lake borders. For example, if we increase the number of triangles on point number 11, it will increase the number of triangles, for example, at 10 as well. So we could modify locally the number of triangles. What does basically, why this could be useful? For example, we have a lake which basically doesn't need any triangles in the middle because there is nothing happening there, but you rather want to keep pretty detailed shoreline because you, for example, vertex bind here something. So you are able to do this by changing the triangle density on the borders, not globally. Okay, So that's about the points. Of course, you have a position here. You could add, remove points between the same situation like you do by mouse. Okay, mesh painting. Basically, you have vertex color, flow map, and vertex height. We will start from vertex color. Vertex color is split into manual painting and automatic painting. Let's start from manual painting. What we could do with our manual painting vertex color on our lake. First of all, we will get all features that are based on vertex color from our materials. For example, for swamp, if we will paint by air channel, we will paint layer 1 of our swamp. If we will paint G channel, we will get layer 2. With B channel, we will just make clean water where we want. Basically, remember that all these lines are because of the blend size and blend strength and the amount of triangles on our mesh. If we will increase the amount of triangles, we will be able to paint more detailed effects. I mean, we will get better resolution of the effects at our lake because we will have more triangle to paint. Okay, but let's back to the alpha. We could just paint alpha. Why not? So all effects that are based on the vertex color could be painted by this marker. I show you at the moment the lake object with swamp layer, but if I will change the material to maybe other material, maybe big yellow lake desert, you will see that first of all, by uh, vertex color, we get small cascade or even cascade layers on the lake. Basically, if you would set up this material differently, I mean, you will replace, maybe remove the foam and remove the foam. Maybe we could even leave this foam on this lake in that place. If you would remove this foam from material, you will have a different normal maps and different lake behave just on the specific area. So, for example, if we will change normal map just for the waterfall, we will get, oh, or maybe for example, I will make a test for you. We have a small cascade here, and we know that at the moment you have foam, but you could generate, for example, such an image. Let's go to the small cascade and remove the foam. And what we have here? We have a lake which is reflective and looks like it doesn't have any wind effects. I mean, the waves are small, but we just painted by vertex color area where the foam, where the waves are bigger, more noisy. So, for example, in the middle of the lake, we have bigger waves, like in natural situation, right? In the middle of the lakes, we have bigger waves because there's a space for a wind effect. So that's what we could achieve at lake materials. So yeah, that's pretty nice effect. Let's maybe restart that. But this is a manual vertex coloring. Maybe let's play with automatic vertex color now. Okay, so I paint the lake with, I'll override the lake with air channel, air vertex color, and we get detail 1. Of course, in the curve option, we could change that. First of all, on the left side of the curve, we have a lake border. So at the lake border, we have a red color equal to 1. On the right side of the curve, we have a first of all, distance from the border. At the moment, it's 1. Let's maybe change the times of the distance from the lake border to 10. And let's set up value, so the vertex color to 0, red channel to 0. And we get, first of all, in the lake border, we get air channel. And in the middle, we have zero water channel, and we back to the typical mix. Of course, we could just move these values higher to lower just by curve. You could simply, mix that a bit just to add additional effects. It's up to you how you set up that. We could do this. We could do the same on the B channel, so which is responsible for the second layer of the swamp, and just you could mix this and create pretty realistic lake effect, which comes from vertex coloring out of the box without painting anything manually, especially when as the lake border is not so straight like we have on the screen, because they are rather curved around the shoreline. So all these effects will be nicely mixed together. To be honest, to create even more realistic effect, I mean, for example, we could find the air channels or algae on the lake borders, and like in real life, in the middle of the swamp, we could place clean water. Probably this would look even better than the mixed swamp lake like we showed before, right? Okay, so let's maybe change the B channel of the vertex color, which also will depend from the distance from the border. So we will simply, find the B channel in a distance. And what we get now? We get a lake with algae on the borders, and we have a clean water in the middle of the lake. I would say it's the most realistic effect. I mean, if you go to the swamp, basically it looks like that. I mean, on the borders you have all mixed algae, but in the middle of the lake you have a clean water. So yeah, you could really play long time with these vertex color features, adjust them, and just everything is on your hands. Okay, so I listed vertex color, and now we could talk about flow map. First of all, there are two flow maps in the lake system. In debug mode, you could see that it basically works the same like in river, but flow map in the lake, basically, it's central, so it push water into lake borders. You see, uh, so this is one flow map option, which is more accurate for lakes. But if you will create sea, for example, or huge lake, maybe you should use directional flow map, which is rather simulate the wind speed on the big water surface. You set up a direction and you get flow map in specific direction. But let's back to the central, as it's more interesting for us at this lake, and let's play with its values. First of all, let's maybe increase the speed and see what will happen if I will play with these settings. Let's go to the debug mode and turn off smooth. And you see that we get area where there is no movement in the middle. You see that water doesn't move here. With automatic distance, we set up distance from the lake border and its blend when water starts to move to the lake border. For example, let's set up 10 like it was before and set up 10 for blending. But it may happen that it's still enough and it stretch the texture. I mean, the blend distance is not enough. That's why we add automatic smooth option. You could increase or decrease smooth. Basically, the higher speed you use in the lake, the higher smooth amount you should have. For lower speed, you could hold lower smooth amount. It's because the flow map must be smooth, so it doesn't forgive any big changes on the flow map in small area. Okay, so you have a smooth amount and distance. Of course, you could add noise to the flow map as well, and you have a flow map physics, which basically is a correlation between flow map, which is from value from -1 to 1, to physical speed. So basically, if you will drop object with our Buoyancy script into the lake, it will move in the flow map direction with speed when where the flow speed will be 20 at flow map equal 1. So that's about the automatic flow map. There is also flow map which you could bind manually. So now let's maybe focus on the manually flow map binding. For manual flow map, let's reduce the automatic speed so it will not make mess on the screen. And we have an option like directional, which will basically move flow map in a specific direction. For example, we could meet two opposite directions in one place. Okay, let's keep it smooth, Okay, we handle that. And we see that it moves from two directions into one place. So this is how directional works. We set up directions, which is also speed, and we move water in that direction. Keep the flow map smooth. Okay, but there is also attraction. Also, we have to keep it smooth, maybe 0.4, and reduce the opacity. Okay, so we start move all water around into one specific place. Opposite to this option is repulsion, so we start to move water outside from one point. You could see in the flow map. There is also smooch tool, which is, I would say, most important tool that we have here. Basically, it will follow your mouse and move water in that direction, and higher speed of the mouse movement you will put, the faster water will move. You see? Maybe let's increase the speed multiplier. 1, maybe it could, okay. You see the water start to move in a specific direction that we place by marker. Okay, but when we use smooch we could use, for example, when one river end at the lake and another river starts from that lake, for example. And in this case, we simply find by smooch tool flow map that moves water from the river and push it to another river. And this flow map will be used by physics. So if any object will fall from this waterfalls, it will be moved into another waterfall. Of course, if this object will cross this line, it will be moved into another direction. This is why the smooch tool is probably the best tool for modifying flow map at the lake. Okay, so that's all about the flow map. Let's play with vertex height. So let's talk about the mesh painting vertex height. First of all, we took debug material and we snap terrain to the snap lake to the terrain, and we see that it it is not accurate enough. If we will increase the number of words, it become more accurate. But there is other way to handle that. You could always use mesh painting, vertex height, and simply cover and move up or down this shape of the lake. So you could simply paint height of the lake surface. It's pretty useful. First of all, you could keep low resolution of the lake and cover whole terrain and fix by painter. The second thing is that let's think about how we could use this snapping and vertex height paint. For example, you have a limit of the texture of the terrain, and you want to paint another texture on the terrain, but you don't want to add it to the terrain. So in such a case, you create material with another texture. You place it on the lake object, and you snap this to the terrain. And how to blend it? For example, use the material with mask, or for example, our materials like we have in lava. So you could paint lava material inside, and outside you leave terrain, I mean texture, which is similar to the terrain texture, so it blends one to one. As but if you use snapping, the lake material also take normals from the objects under the lake, so you get blend one to one. Okay, now let's play with terrain painting. Let's borrow a lake to other place. Let's make it a bit smaller. Okay. So how terrain works? First of all, you have terrain carving, painting, and manage for it. It's based on the profiles, which are the same for rivers, lakes, and terrain painting objects. So basically, if you create such a profile, you could share between multiple objects like we did on the demo stream. Let's first start from carving. You have a debug mode, which will show you how by this lake. So you are able to set blending between existing and gold terrain. You could expand the the carving outside the lake as well. So for example, we could have almost whole terrain like that. Okay, let's leave it to 10. And yeah, let's maybe look at the curve, because you could see that the river depth in the middle is the biggest, because it's, for example, about 20 meters from the lake border, so its depth should be around here. But if you are close to the terrain borders, the depth will be somewhere here. But if you could also carve outside the lake border, so if this point is on the time on minus, it's outside the lake. 0 is the line border. So yeah, you could carve it with noises or without. Let's maybe carve it, and we get carved lake. Let's focus on painting now. Okay, painting. It's also based on the profiles. So all this painting setting is saved in the profiles. So if you simply click drag and drop profile and click paint, you will paint the terrain under the lake. Of course, you could easily change it to totally different rules and get totally different painting. In fact, you could paint outside the lake as well. Let's back to the original lake rules, and to paint outside the lake in each layer, because it could be separated case. For example, sand will be painted to this area while rocks will be painted in longer distance. To paint outside the lake, you simply change the time on the spline, for example, to -30. And if you will click paint, you will see that it starts to painting outside the lake. If I will move this spline a bit higher, the longer will be distance of the painting, up to -30 meters. So let's maybe set this back to 0. And okay, so you could paint outside the lake. You could paint by height, for example, like we did in our sea, because it's also a lake object. It paints sand only to a specific height. You could paint by angle. As you could see, for example, rocks are painted by a specific angle, so the texture will start to appear only in a specific angle. You could of course noise that, so the spline will be really messed, but it will give the best result probably. And you could paint with noise and without, and convex and by convex and concave rules, which is not visible on the lake object, but for example, for our terrain painters, which will analyze the very difficult terrain shape, they simply work well with these rules because it highlights the shape of the terrain, right? Convex and concave areas. So in lake where the shape is rather not so noisy, because it's simply curved by spline curve, you will not notice big difference without setting that, but for whole terrain painting it's pretty important. So that's why, yeah, it's a good idea to use this convex and concave rules. So about painting, it's all. If you want to manage foliage, you have a distance for trees and foliage separately, in which lake will simply remove foliage from the borders and in a distance. So that's all for the terrain. Let's finish this lake with simulation. Okay, so another cool option is a simulation. If we create lake polygon, we place one point. For example, let's move it into middle. We choose a profile. Let's take lake mirror. We go to simulation, and we could leave options as they are, or we could change them. Basically, angle is a resolution, so how often in angle we throw raycast for search and collision. Point distance, how often we place points on the shoreline, and check distance, how far we throw raycast for searching the collision. If we click simulate, we get pretty nice lake out of the box. If we would increase these values, we will make it more fit the shoreline, I mean the points. But in fact, if you will going to use terrain, carving, and painting, you don't need to increase the resolution of the points, because you will simply match the terrain to the lake border. So the simulation gives you the first initial shape more or less accurate to the area, to the terrain, but then you just carve and paint the terrain under the lake. So it will fit perfectly without putting huge amount of points to highlight all this terrain shape lines, right? So Yeah, that's all about simulate. In file points, you could export these points or import points to create lake. For example, you could take real data and load it as a CSV file to create lake in Unity. So it's all about the lake object. SIA object will be more complicated and I will make separate tutorial for that. See you.